Everyone, welcome back to SAT Math Question of the Day. This comes from an educator site. This question may appear on a Blue Book test, so just a little bit of a spoiler alert there. Okay, Keenan made 32 cups of vegetable broth. Keenan then filled X small jars and Y large jars with all the vegetable broth he made. The equation 3x plus 5y equals 32 represents the situation which best is the interpretation of 5y in this context. I know I made a mistake the last time this problem came up where I said what 5 was, not 5y. So you have to be really careful. I made that mistake once. I'm not going to make it again. So 5y is the amount of cups. Oops. It's a good unit analysis here. The 5y has to be the units of cups because 5y has to be the same units as 32. So the answer is going to be in cups. So it's cups, number of, or jars. No, cups, not jars. Confusing, right? Total number of cups. So what is the y thing? The y thing is large jars, right? Large jars. So it would have to be the large jars. The number of cups in the large jars. Because 32 is in cups. 5 times y is part of is that little term. And the y refers to the large jars. So it would have to be C.
Okay. Well, I want to read the problem and write down what we should think when reading the words.
Okay.
So, Kenan made 32 cups of...
Keenan
made 32 cups of vegetable broth. Next sentence, important. Keenan then filled X small jars and the other stuff. So I'm going to circle X small jars and then write down that.
Go below because we can't see you. Right below, right down.
Is that okay?
Perfect.
I will write down what X represents. X is the
number. Exactly.
Is very the number of small jars.
Why do you care about that?
Because I'm reading it.
Yeah, but people don't have time. You don't have time to read. You got to answer the question. This is an SAT test.
No. We need to visualize the situation because it says the equation represents the situation.
Yeah.
So we should aim to think or feel that when we read this, we know we feel what X is. X is a number, a counting of the small jars that he filled. In the same way, Y is the number. In other words, how many?
Right.
Large.
Okay, move on.
No? Okay, I have to finish it. You write it all out. He filled. You write it all out. Okay?
Okay.
And then this says, therefore, and the situation is that there is a 32 cup quantity of broth.
Yeah.
And so it says that so then you think about this. 3y is the amount of broth that are in the small jars, and 5y is the amount of broth is in the 5 is in the big jars. You add them, the total amount of broth. Amount of broth is measured in units of cups. So that leads you immediately to what they're asking, the answer for what they're asking. What is the interpretation of 5y? It's the total number of vegetable broth in the large jars.
Okay. Okay. Fine. So we agree.
So what you have to, when you say X is the large jars, that's what you said, Joel.
Yeah, that's wrong.
That is wrong.
That's
but
wrong.
The feeling you need to get is it is the large jars in the sense of being the number of large jars.
Yes, absolutely right. You are completely right. I made a mistake, but in this case, you got it. Yeah, okay, fine. I felt that, but I said it wrong.
Well, so what we're trying to do is let you know what we think when we demonstrate solving the problem.
Right.
So to learn to solve these problems, you would learn what to think when you read the words of a math problem.
Yeah, in fact, if I was giving this test, let's say, if I was going to give this question on, let's say, a school test, I would ask it this way. I would say, please, what is the interpretation of the 3, the X, the 5, and the Y? And everyone would have to write it in English. And if many people will, for the X, they'll say small jars. They would say X small jars. They would say X is X small jars. That would be completely wrong. You would have to say let X be the number of small jars, or let X be the number of small jars he filled. We don't have to be technical about the he filled, okay?
Well, the thing is, they did say X. They did write X small jars.
I know, but it's not. It's then they should have said let X, then Ken filled X number of small jars. That would have been.
However, suppose you wrote something in English. I have 9 small jars.
Right.
Okay, this is easy to understand standard English, and its meaning is that 9, when you understand English, or you understand the translation of this sentence in any other language, you get the sense of what's happening.
Right.
So if someone would ask, what is the 9? You don't say 9 is the small jars.
Exactly.
9
Absolutely.
is the number of small jars.
Absolutely right. It is
and
so
then the progression of this sentence involving arithmetic, the progression to algebra is I have X
number of.
No.
I have X small jars.
Yeah, so this is analogous English, and it's perfectly clear.
Right.
It is perfectly clear once you get used to, what they teach in algebra, using letters,
right,
to stand for numbers.
Yeah. Well, generally, when you have problems like these, if you're going to do a let statement, which you should do for every single word problem, or really almost like every single word problem, when you write the let statement, you have to prefer to say, well, you really got to say, let X equal the number of small jars, not
yes.
not let X equal jars. But if you but if you're running out of time and you got to rush, as long as you know that X is a number of small jars, you could just say to yourself, okay, X number, X jars. Okay, because you got to get the question done quickly. They call this a hard question. I mean, it seems like it's a straightforward question. It doesn't necessarily seem that hard. Of course, we know how to do it. We've also seen questions like this before. Seems like the digital SAT repeats a lot of question types. And I do remember when we did this question a few months ago, I jumped for the 5 and I looked for the answer of 5, which is the number of jars, the number of cups in each jar. Now, I can't believe they didn't put that as one of the choices for the people who would jump and just look at what the 5 means. I'm shocked because when this question we did this a few months ago, they had the wrong answer here. They had a distractor saying it's 5. It's the number of cups in each large jar, which was
it's a lot. They could vary it a lot.
Yeah, they could vary it a lot. So, but okay. So I guess today's Throwback Thursday. So today, so we're going to go through this and hopefully get to our Throwback Thursday question.
Well, we should do our 4 questions and then look at their explanation.
Absolutely, we do that first. So first of all, calculator. I mean, of course, calculator is no help at all. Starting with the guesses, not really. It's patterns. There's no pattern to that.
No. I think the choices are good to give you a clue and to clarify or satisfy yourself about what they're asking for.
Right.
So I think it doesn't hurt to read the choices.
Right. It doesn't hurt to read the choices, but the process of using each choice and testing it in the problem, I don't think applies. But yes, of course, you almost always want to look at the choices on any question. But it does help here. Okay, patterns. Now, there's nothing special about these numbers. They could have made that a 6y or a 4.5y. There's no pattern to this that makes you go faster. Is this different from a school test? Usually school tests are not multiple choice questions, but if the teachers want to steal this from the educator site and throw it on their test, fine. And the main idea, which is the most important question, what were the test people, what was the test committee people sat on the committee, what did they want to see you knew, what you knew? So
I'd say they're testing your understanding of the language of word problems and algebra.
Yes. And it's a very, very common problem. Even in a lot of standardized tests around the country, they ask, what is the best interpretation of something in the formula?
Yeah, so what they're testing is they're testing the how well they're testing how you understand the application of algebra in word problems.
Yeah.
So how is that different from other things? Well, another element of algebra, which is different from that, is algebraic operations.
Right.
You could do algebraic operations. You could do algebraic operations.
Right.
Without any interpretation,
of course,
given for the expressions.
Right. That's right. Yeah.
That's a different. So it's another component of the subject of algebra, but it's different from this.
Right. Yeah. Okay. So I think we're done with this. I guess we could now look at their answers and see how they do it. We'll see, because this is a very qualitative question. So let's see what they say. We just have to make a small adjustment here. Let's see. We go like this, and we go like this. Okay, we'll let you agree with our answer. So again, just bear with me. Okay, choice C is correct. It's given that that equation represents a Chaikin-filled small jars. Okay. Therefore, the 3x, who cares about the 3x? Because they're asking for 5y. But they're doing it the great minds think alike, Seth. You also went into the x thing. Therefore, 3x represents the total number of cups of vegetable broth in the small jar, and 5y represents the total number of cups in the large jar. I don't know if it's a therefore. They're not really explaining it that well. They just say therefore. They're not really explaining why they say that. Wait, so that's it. That's not a very satisfying explanation if you don't know what to do. They're just saying this is the answer. But so it's weird that they call this a difficult problem, especially since the answer, see, difficulty level 3 of 3. The answer is so short. A difficult problem shouldn't have an answer that's only 3 lines. A little weird. Do you have any comments on their answer?
Well, they don't give an abstract discussion like I did about the languages and the issue of understanding languages.
Yeah. And they also don't give this little powerful concept that I used of let the units help you in the problem.
Yeah.
The answer, because 5y is sitting there at the same level or the same, just sitting there as the 32 is, the units of 5 times y has got to have the same units as 32. So the only 2 answers that have cups as their units are C and D. You could do a lot of damage in a problem, a lot of good really figuring out what some of the answers are by just looking at the units. And we've been talking about that for years, literally years. Okay, so I guess today's Throwback Thursday. So we go back to a test from, I don't know, 20 years ago, 20 years ago, the old style books, where the test had a different feel. Some of the questions had a different feel, and you'll get a sense. So let us move on to that. This is our Throwback Thursday question of the week. So we do this, and then we go like this. Wait. Let's make this smaller so it'll fit here. Move us around a little bit. That'll do. Oh. Okay. There we go. So, okay, bring in the annotation. And we are ready to go. There we go. It's a little small. Okay. The figure above, notice how weird it looks, is formed by connecting perpendicular line segments. That's going to be important, I'm sure. Oh, I'm sorry. I'm not supposed to comment. That have lengths as shown. What is the length of the dashed line segment? So, okay, I guess.
Okay, all I would do is add construction lines.
So I'm going to move things around a little bit just to annoy you. Ready?
Ready.
Oops. Okay, so please, let's, okay, so I'm just.
It doesn't matter.
No, you got to knock those lines. You got to delete those lines.
I will. I'm taking care of it.
Thank you.
Okay. So here we go. So my approach here is we want to find the length of the dashed line. And so what tells me is that we should use the Pythagorean theorem. And you can get a clue to use the Pythagorean theorem because some of the choices involve square roots. And so what I do is add construction lines. I extend this horizontal line horizontally, and then I drop a perpendicular from the last point.
Yep.
And now I realize that I could find the answer if I knew the lengths of these line segments.
Yep.
Between the black dots and the red dots. So the
Right.
problem is to figure out these lengths.
It's
So
not
now,
so obvious, but you should be able to do that. Can you do
and
that? I don't
now
know.
what I do is do more construction lines to help figure out these lengths. So here we go. Here we go. This length from here to here is equal. If I pull a vertical here, this length is equal to this. And so I have to figure out what that is. That's a pain. Oh, wow. So, let's see. Okay. Let me think. So I need to figure out this vertical line. Right. So this vertical line, I extend this way, and I get that. Let's see. This is 1. This is 1. And therefore, this is 2. Therefore, this is 2. And therefore, this is 2. Now, I also have to figure out, let's see, gosh, this is confusing. So Joel figured out that this is 2.
Yeah, because that's 9 minus 7.
Okay, so we conclude that from here to here is 4.
Right.
Now, so let's see. This is 2. Can we conclude that the line is 45 degrees?
I don't know. Is there enough given information to prove that geometrically? Well, yeah. I mean, if you're claiming that these things are the same, then isn't that a 45 degree triangle?
How do we know they're the same? How do we know that they're the same?
You're the one who marked it.
Okay, well, this is equal to 3.
Oh, you're right. It's 5 and 3. Right. Yeah, it's 5
this
minus
is 3.
Yeah.
Therefore, this is 2.
That's right.
So therefore, since these two therefore, since the two sides of this region are both 2, it's a square. Therefore, the line is 45 degrees.
Right.
So we know that this triangle is the triangle is 4 by 4.
You maybe went outside. You got to move over
what that is
to the left.
Right.
I'll help Seth.
So it's 4 times the square root of 2.
Right. That's knowing something about the 45 degree right triangle. If not, you could use the Pythagorean theorem that the answer is the square root of 4 squared plus 4 squared, which is the square root of 16 plus 16, which is the square root of 32, which is the square root of 16 square root of 16 square root of 2, which is equal to 4 radical 2. Or you're familiar with the 45 degree right triangle.
Yeah.
So this is called geometric eye. There are, if you don't look carefully, this is a really, really hard problem. If you don't see what Seth saw here, there may be other ways to do it. By the way, there may be other insights to get the fact that one of these sides is 4.
Oh yeah. Okay, I have one. I have an
maybe
insight.
There's an easier one. Let's show them all.
Here's another insight.
Let's show them all.
Imagine that you're a bug, or imagine you're a taxi cab driver.
Okay.
Or an Uber driver.
Yep.
And you want you want to figure out. Uber. I'll use brown for Uber. You want to figure out how far you have to go east to get from this brown dot, the left-hand brown dot, to the right-hand brown dot.
Okay.
So you can get to by going distances that you know.
Yeah.
So you can go from brown dot A to brown dot B by the following route. You go down by 1, which does not change how far you are east and west.
Right.
So you forget about the 1. And then you go west by 3. And you record that you went west by 3. And then you go north by 3. But we're only interested in how far you're going east-west. So you forget it.
Right.
And then you go east by 5. And then you go south. They tell you how far that is. That's 5. So ignore it. And then you go west by 7.
Oh, Seth, come on. Oh,
This is another approach.
That's a ridiculous.
And then you go north by 7.
Come on.
Let me see if I get the same answer.
That's crazy.
Ignore it because I'm only interested in how far east-west I go. And then I go east by 9.
Are you kidding me?
And then I go south by 4. Ignore it. So how far east did I go? I add up the easts. 5 plus 9, and subtract the wests, the amount of distances. I go west, minus 3 and minus 7. And you add this up. So what do we get?
Well, I don't know. You get, Seth, if you're going to do it that way, write it down the way you're going. First you go -3, then you go +5, then you go -7, then you go +9. And you let's see. Right, so that's how I would do it. If you're going to do it this crazy way, that's what I would do. Yeah. It's sort of like vectors. It's vector, directional line segments. So this is
okay. That is what I thought. That's what the concept of vector led me to this, but since we're giving an elementary discussion, I omitted it.
Right, exactly.
I used the idea of vectors, without using the vocabulary of vectors.
Okay, so someone's in 11th grade have heard the word vector. That's what we're doing, but we don't use the word vector. We just say direction, directed line segments. Pay attention to the directions. You see, when you go, this is considered the positive direction. So if you're going 3. This way, you give yourself a -3, and then you give yourself a +5, and then you give yourself a -7 or +9. It doesn't matter whether you go up or down; it doesn't make a difference, and then you get the answer.
Yeah,
that's not. At first, I thought it was a really ridiculous way of doing it, but it's not bad. It's not bad. But you could also. I just realized, as you were talking, you could also just sort of do what I did. You can sort of see that. This is a 3, and this is a 5, so this is a 2.
Yeah.
And this is a 9, and this is a 7, so this is a 2, so this is a 4.
Yeah.
But then you have to justify the 45-degree angle, which means you have to justify that this is a 3 and this is a 1, so that makes this a 2. And then you're justified to use the 45-degree triangle.
Yeah.
So, yes, Seth, you're right. If you use this approach where you just add and subtract, whether you go positive or negative direction, you don't have to figure out that it's a 45-degree angle.
Yeah.
The other way.
Indeed. This problem could be modified. You could change some of those numbers and have the same shape. But when you make a change in any one of in fact, all the numbers are independent. If you say increase, say you increase this 3, increase is 3. What will happen is it will move the B line, the B point, a little bit to the left. And it will not change. It will move the B point a little bit to the left. It will not change the heights, and it will destroy the fact that the dashed line is 45 degrees.
So we don't do the 5 questions in here, but certainly there is a pattern here that one can help. It really helps that it's this triangle here is an isosceles right triangle, which really, really helps you do the problem, which means that you can see it quicker. Okay.
Well, I think this problem you'd get the right answer if you simply assumed from the look of the diagram that the dashed line was 45 degrees.
Oh, but this is an interesting question. Is there a way to deduce from the dimensions this height 4? Do they give you enough information to get the 4? They tell you that this is not... Wait, they tell you this is...
Of course.
Wait, so how do you do that? They tell you this is 5. Oops, that's too much. That's too much. So let's go thinner with a other color.
No. The original figure was
yeah, you could figure out it's a 4. You could figure out it's a 4 directly.
No. The original figure is this. It's a spiral.
Except you're going over. You can't go there. You can't draw there. No one sees it.
All right, where can I draw it? Can I draw it to the left? Where?
Draw it in this box.
Okay. Here we are.
But yes, you could get this dimension.
No, the thing is, every single number in the figure, is independent and is critical for determining the answer.
Yeah.
Okay. Right. So you cannot deduce that the length of the last of that last segment is 4.
Of course you can, Seth. Of course you can. Of course you can. Look.
No. You cannot deduce that without assuming that the dashed line was 45 degrees.
No, of course you can. Of course you
cannot figure out the 4.
Seth, watch. No. Okay, follow me.
Because they don't tell you. They don't tell you that the line segment between A and B is horizontal.
Okay, well, come on.
They show it in the diagram, but they don't tell you that.
Wait, you drew the line segment between A and B. You drew that.
I drew it.
So you made it horizontal.
I made it horizontal because it was horizontal.
So, yeah, okay.
The figure is drawn to scale. I simply drew in the line, and it appears horizontal because it is horizontal.
Okay.
But if the thing is, you could change. So this is what it says. The figure above is formed by connecting perpendicular line segments,
right,
that have lengths as shown.
Right.
Well, you could take so there are how many is 1, 2, 3, 4, 5, 6, 7, 8, 9 line segments.
Right.
You could take 9 arbitrary lengths.
Yeah.
And join line segments of those lengths successively, horizontally and vertically.
Yeah. Okay.
Okay.
Right.
only the particular lengths that this problem gave you results in the starting point ending up. The starting point ends up on this ends up uh, you know and the starting point and the ending point ends up at a horizontal angle.
Okay, yeah, okay.
So the thing is, that's use your imagination. Imagine any one of these numbers is changed a little
No,
bit.
we're
How
not
would
going to
that
mention
change?
anything. We're just going to do this problem.
Yeah. So again, the issue, the thing is, the issue is that you really need to take into account all of the numbers
Yeah,
they gave.
right, right, right. But first of all, if you drew this horizontal line, because it's perpendicular, because these lines are all perpendicular, you can prove that this orange line that I'm making a mess of, is parallel to the other lines, because you made it perpendicular and all these other lines are perpendicular. So you know that this is going to be horizontal.
No, no, no. The two vertical orange lines are vertical
Yeah,
because they coincide with lines that are given.
yeah.
But the first line that I drew from A to B,
Yeah.
please imagine it.
I'm
Change
not
one of the
imagining
numbers.
anything. I'm not
Change
imagining.
change change
No.
change change one of the vertical distances.
Look, you drew a
That will
line.
cause line AB to stop being horizontal.
You mean it not? You mean that'll choose line AB not be perpendicular to the vertical lines?
That's right.
Yeah, but you made it. You drew it perpendicular to one of the.
I drew it by joining A to B in
Yeah.
the diagram they gave.
No, but you could also draw it as a perpendicular to, let's say, this line. You could do
I
it.
could have, yeah,
Yeah,
but
and if
then
you
there's
do
be
that,
no guarantee.
you're guaranteed. If this is perpendicular, then you're guaranteed that this
There's
is
no if
also
I drew if I
perpendicular.
say okay, start at point one and drop and draw a perpendicular. Start at point one,
Yeah.
start at point A,
Right.
and draw a horizontal line. There is no guarantee without the numbers that horizontal line will meet the final vertex of the figure.
But I could always draw a
Why?
horizontal line.
Why? Change the 4.
Seth, I could
Make the
always
4 into a 5.
Seth.
That will cause.
I
If you
know,
change the
but I
4
could
to a
always
5,
draw a line. I could always draw a line perpendicular from A. I can always draw a line from A perpendicular to this line. Perpendicular to this line. I could
of
always do
course,
that.
but
I
of
could
course,
always
yeah,
do that.
there's no guarantee that where the line that you draw perpendicular meets the orange line, where it's no guarantee that it will meet it at the dot in the figure.
Right, but you're guaranteed that if it's a perpendicular line here, it's also perpendicular here.
Yeah, sure. Yeah.
Right.
Yeah.
And if it's perpendicular there, does it guarantee that it meets there? Maybe. If it's perpendicular, is it guaranteed
I think
that it
what you need
meets
to do,
here?
Joel, is use your imagination and see how the figure changes if you take any one of the any one of the numbers they gave
Right.
and
Yeah.
change it a little bit.
Right. So in other words, if you start here and you go here, 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 but this is a little high. This is a little higher than it's normally. So that means this is going to be like this. That means this is going to be a little high.
Yeah.
Yeah, okay. Fine. So then you would go there.
Finish it off. There you no
No, I went too far.
You didn't make it a little high.
I did. I made this a little high. Look, I made it a little high. See, it's not, this should be straight. See, I made it a little high.
Yeah. If you made it a little high, and then you still went down by 4.
I know, it would not be a right triangle.
If you made this a little high,
it would come there.
That would cause this dot to be high.
Right. Yeah.
It's high relative to the starting point. Right.
So then
this line would not be horizontal.
Yeah, but I could draw a perpendicular here.
Yeah, of course. Yeah, me too. Yeah, you could draw. Yeah, so this perpendicular, this is the perpendicular.
Right.
Through the starting point.
Yeah.
And the brown line is the line joining the 2 endpoints of the figure.
Yeah. But I could still do the problem. It would be harder, but I could still figure that all out.
Yes, indeed. So
because
in order to do the problem, you have to do the calculations.
Yeah.
Of how far to the east is the second brown point.
Right.
From the start, and then separately calculate how far north is the second brown point from the first brown point. Yeah. You have those 2 figures of north displacement and west and east displacement. You take those 2 numbers, you sum their squares and take the square root, and that's the answer.
Right. Or use trig. You can use trig, can't you? If you knew the angles.
But you don't know the angle.
Yeah, but you know their rate. You can figure out what their sines and cosines are.
You know the 2 sides of the right triangle.
Yeah, right. Then you can get.
If you know 2 sides of a right triangle, the immediate way to figure out the length of the hypotenuse is just do Pythagorean theorem.
Right. Yeah. Okay, you're right, but. Okay, but the thing is, if you had this problem, it would be if it's as what you said, it would be a much harder problem, much more involved.
Yes, it would. Yeah.
So in other words, you have to.
And and this is a misleading problem. This problem teaches people misleading habits of thought.
Yeah. But the bottom line is you could also get the 4, as I was starting the discussion. You can get this 4 by adding and subtracting vertical heights. No, if you make the assumption of that, as we did, that the line is straight, of course you can, because if this distance is 2 and this distance is 2, because this whole distance is 5 and this distance is 7. So the difference here is 2 and that this distance here is 2. We showed that before, so that you can see this is 4 and this is 4.
No.
Of course you can.
No. It's contradictory because the same data, same problem. You could change the 4. You could change the 4 and still have a analogous figure.
Right.
So you can't determine the 4 from the given information.
Wait, hold on. Wait 1 second. Wait, hold on.
Again, I keep saying it. You don't understand. You don't understand that the figure was drawn to scale.
Right. Yeah.
And as a result of drawing the figure to scale, the angles came out
right
to be the true angles.
7 minus 5 is 2. 3
Okay, let's see.
minus 1 is
Let's see.
2.
Let's see.
So there's a 4. 7 minus 5 is 2. There's the
Okay,
7.
let
There's the 5.
me see. Let me think about this a second. So,
And there's the 3 minus 1 is 2.
yeah. So seven minus 5. That I agree that tells you this segment is 2.
Right.
Now, what about this segment?
It's 3 minus 1.
How do you know that's 2?
You did that already. Seth, you yourself.
No. Given the start, we're starting with the figure only.
Yeah.
I agree that if you draw what you did was you extended this line horizontally.
Yeah.
Good. Now you drop the vertical.
Right.
Okay, you dropped a vertical. Oh.
You yourself got the 2. You yourself justified the 2 here. It's the same justification.
I got it now. Okay, I think this is the issue. I'm sorry, this is the issue. We messed up the figure so much that I forgot that the original data ended here.
Okay.
That is what we're arguing about.
I
had forgotten that the given the figure above with the line segments, I had forgotten that this figure has 1, 2, 3, 4, 5, 6, 7, 8, 9 line segments.
Okay.
What I did was drop the perpendicular from the brown dot and the horizontal from the other brown dot, and I had forgotten that the line that I drew, I had forgotten that I added it.
Right.
I had mistakenly my memory was mistaken in that I misrecollected that the line segment was part of the input with its length of 4.
Oh, okay.
So that's the problem. That's why we're arguing about this. So if you say maybe a big idea to clear the scribbling.
Yeah, sure. My pleasure.
Clear the scribbling. Okay, and so we could figure out.
Yeah, Seth, we did it already. You don't have to redo it. We did it.
Okay.
Problem solved.
Good.
We don't have to torture.
We got it.
We don't have to torture our audience.
Again, the whole point, the reason for adding the construction line, was to make the dashed line become the hypotenuse of a right triangle.
That's right. Yeah. Now Seth swooped in and started doing the problem. So I personally could not vouch for how I would have done it. I never had the chance, which is fine. We worked together, which is fine. Okay. But what I must say one thing about geometry. I always say it. It's like my mantra with geometry. When in doubt, if you're in a geometry problem, when in doubt, draw perpendiculars. All radii are equal, and when you're really in trouble, which is not this one, but when you're really in trouble in geometry problem, look for similar figures. So that's what I always say. Because fiddling with figures is useful for problems that seem hopeless, but not this one. You're just dropping perpendiculars here will do it. So, okay, that's it. Oh, we forgot to introduce ourselves. I'm Joel. I have a PhD in mechanical engineering. Brother Seth, like a real brother, not a real like genetic brother, is a PhD in math. And we try to meet every day to offer our suggestions on how to do an SAT math question. We hope that you find this helpful. We look at the approaches and really ideas and concepts behind the questions more than anything else, because we know those approaches and concepts are going to reappear on a lot of questions. While we can't predict the actual question, we can predict that these concepts and approaches can be used. Well, the concepts will occur and the approaches hopefully be useful. Sometimes we have different approaches with different people, so we offer that. Take as many practice questions as you can. Take all the Blue Book tests. We've heard rumors that Blue Book 4 and Blue Book 6 are the closest to the actual SAT, so pay attention to those, at least on the math side. And if you have any weakness in any topics, go to the Khan Academy digital website, digital course, and practice up on the topics that you're weaker on, and also get really fast on the topics you're strong on, so you have time to ponder the harder questions on the digital SAT. So please give us your comments on our videos. We take all the comments very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Anything else, Seth?
No.
No, I think we're done. I hope people got an appreciation. This question, I guess, could appear on a digital SAT, but just physically looks a little weird. But I guess it could occur. But again, it has a different feel from the more modern tests.
I think you pointed out to me on the web a collection of problems like this, where you're given some of the lengths in a figure, and you have to calculate the others.
Yeah, it's like a line segment puzzle. They have these
it's called a line
segment puzzle. They also have the angle puzzles. They give you a slew of angles, and you figure out all the angles, or they give you line segments, and so if people want to practice this, just Google line segment puzzles or angle puzzles, and you'll find slew of problems. And then, of course, you have the big famous big circle problems. Have you ever done big circle problems in high school? Did you ever see a big circle problem? I'll send it to you. Where you have a big circle, and you got all this stuff. You've got secants and tangents and crazy things going on. And then they label every angle, 1, 2, 3, 4, up to 20 angles.
So the big. So this is defining all of the trigonometric functions. Using one circle.
No, it has nothing to do with sine, cosine, and tangent. It has to do with the circle theorems. It has to do with all the
circle. What theorem are you talking about?
Oh, it has to do with all the circle theorems.
What is the circle theorem?
There are 15 of them. 20 of them. 15, 20 of these things. Wait. The circle is called the circle theorems. At least I call them the circle theorems. Forgot the circle theorems? You have a PhD in math.
There are many theorems.
There are many. Like, for example, here's a classic circle theorem, okay? This would be like in a big circle problem. You have a circle, and you have a tangent and a secant. So the angle A, and this is arc B, and this is arc C. So angle A is 1/2 arc C minus arc B. But then you have all this other stuff, and then you have this thing going in, right? And this is the inscribed angle, and this is arc D, and this is angle F or E.
Yeah.
So angle E is 1/2 arc D, and then you're throwing all sorts of stuff, and you make another tangent here. You get another.
So you're talking about relationships between arc angles and
And lines.
What would you call arc angle measurements,
Yeah, with
arc angle
tangents,
measures,
cants, yeah, all this stuff.
and angles between lines that touch the circle in
Yeah,
various
I can
ways.
send you some. You
Okay.
want? If you have you could put like 20 angles. You could put 30 angles on this thing, and then you got to figure them all out.
Oh, so that's an angle puzzle.
Yeah, but it's a circle angle puzzle. It's called the big circle puzzles. They're called big circle puzzles.
Big circle puzzle.
Yeah, because you have a big circle and you got like 30 angles, and when you look at these
Oh,
things, they look
so it's a
insane.
big circle puzzle,
Yeah.
not a big circle theorem.
No, no, no. It's not a big circle theorem. It's a big circle angle puzzle. It's a type of angle puzzle that involves a big
Okay,
circle.
okay, good. I think because you said big circle theorem.
No, no, no. It's the big circle angle puzzle. Sorry for the not being clear. Anyway, I think we're done, right?
Okay.
Okay, everyone. Have a great day. I hope you got something out of today's regular and the Throwback Thursday question. Okay, everyone. Have a great day.